Hi, our work is under the title Enhanced Gaining Sharing Knowledge Optimization Algorithm for 3D Compression of Intrusion Detection Dataset. As we know, intrusion is accessing and entering the network or a particular computer to spy on the information on it, steal data, change the system, or obtain security holes in the operating system to destroy it. For these reasons, there was a need to use a system to detect intrusion and reduce the risk related to network security and personal computer security. An intrusion detection system is a software or hardware system that monitors the networks for suspicious movement and has primary duties such as network monitoring, breach detection, and reporting to the administrator. The study addressed challenges associated with intrusion detection datasets in terms of high dimensionality by adopting a new method to reduce their size and improve efficiency. Gaining sharing knowledge optimization algorithm is a revolutionary optimization based on human knowledge that has been created in recent years. The GSK algorithm is built on how people learn and impart knowledge throughout their lives. Junior and senior are the two major stages of the GSK, representing gaining knowledge and sharing it. Initially, all members of the population don't possess any knowledge in the junior level, but as soon as they begin to interact with the environment around them, they will acquire knowledge and then be able to share it with other people. Thus, the interaction will increase. They will acquire more knowledge and they can reach the senior level. In the GSK algorithm, the first population is generated at random within border restriction, and then the dimension of the two stages are calculated. The junior dimension is calculated as the following equation, where d of j is the dimension of junior, the d is the dimension of population, the g max is the max number of generation, the g is the current number of generation, and the k is the knowledge rate that determines the experience rate. While the senior dimension is calculated by minus the dimension of population from the dimension of junior. To build the model that will perform the training and testing process, we use the multi-layer perceptron, which is a feed-forward neural network that transfers data from the input layer to the output layer in a forward direction. One of the most popular datasets that have been used to evaluate the work of intrusion detection technique is the KDD-CUB99 dataset. The 57 different attack types in the KDD-CUB dataset make it a big reservoir of attack vector and IDS. KDD-CUB contains two separate datasets, one for returning with the size 494,021 and the other for testing with size 311,029. Table 1 shows the number of each type of attack and the number of normal packets. The most important things to know is that the number of type of attack in the training set is 22, while in the test set is 39. This means that there are types of attack in the test set that are not present in the training set. GSK CIDD model consists of 4 layers. The first layer is called pre-processing, the second layer is called GSK developed kernel, the third layer is called filtering, and the fourth layer is called MLP. The block diagram of GSK CIDD in the first stage, after reading the KDD-CUB training and testing dataset file, the first step is to check the dataset for missing value and then convert categorical data to numerical data to make the dataset easy to handle by the algorithm. The original data is transformed linearly by min-max normalization. In the next step, take into account the smallest and largest value in each feature and performing the scaling. All scale data will be within the range 0-1. The most and the least important features after performing PCEIG, which result in a set of 20 features. During stage 2, the most important features will undergo 2 parallel phases, calculating the fitness function using 7 metrics and then evaluating the fitness function. Modifying the performance of the GSK algorithm by changing its kernel by computing fitness function such as the recombination method, discrete, extended line, extended intermediate, and fuzzy. Then testing their performance using the active function to choose the best one. In addition to the recombination method, person correlation, entropy, and information gain were also calculated as a fitness function. In stage 3, the GSK algorithm is used to rearrange the population based on their fitness value and identify individuals with the best traits and behavior. The records are then rearranged in ascending order according to their update fitness value to identify nodes that generate the least percentage of useful information, which are considered attack. To compress the data and the record dimension, the next step is to cluster the data into groups using Euclidean distance. There are two case studies to consider. The first one, the training dataset size is reduced by filtering record with unequal distances. That means unequal fitness value, or from those with equal fitness value, resulting in a two group. The group with unequal fitness value is filtered, reducing the training dataset size by 20%, while the second group of record with equal fitness value is passed to the next stage. In the second case study, both the training and testing dataset size is reduced by filtering record with the normal target. The test dataset will undergo the same stage as the training dataset. The group that comprises record with a normal target is filtered from both training and testing dataset and result in reducing the dataset size by 19.69% and 19.48% respectively, while the second group is passed to the next stage. In the fourth stage, the MLP algorithm will implement to train and test the model and then compute the accuracy and the time for the model. Table 2 shows the most important features that were selected from the dataset based on correlation measure, which number 20 features, as well as the less important features that will be neglected in the remaining stage, which number 21 features. Table 3 shows the statistical results for the 7 metrics that were used to replace the fitness function for the optimization algorithm and choose the best among them based on the ACLI evaluation. In Figure 4, after testing various fitness functions, it's found that the Busy recombination function is the best fit for the ACLI function and is chosen as the kernel for the GSK algorithm. Figure 4 provides a visual representation for 100 record of duration for using the Busy fitness function as the GSK algorithm kernel. The main benefit of this approach is that it provides a more effective method for identifying and selecting important records for intrusion detection model, then improving accuracy and efficiency. In Table 4, show the clustering process between the fitness value and their number. It's clear from the table that the completely similar fitness value are 395,191 out of the total number of the training data sets. In Table 5, the MLP algorithm is used to train and test the datasets in 3 cases: the original training dataset after reprocessing, the training dataset after feature selection, and the dataset after record filtering. Accuracy and testing time are measured and compared for the 3 cases. It's clear from Table 5 that the proposed method is efficient in terms of increasing accuracy and reducing the time required by the model. Figure 4 and Figure 5 clearly show that the proposed model for reducing dataset size has significantly improved accuracy and reduced implementation time. The results also indicate that filtering record with normal target yields better results than filtering record with different fitness value. While both methods were effective, the normal filtering method proved to be superior. The main benefit of this approach is that it provides a reliable and efficient method for reducing dataset size and improving accuracy of intrusion detection model, which can lead to better system performance and increased security. The study proposed 2 new methods to reduce the size of intrusion detection dataset, which are known to contain redundant and unimportant data. The GSK algorithm is developed and employed to identify nodes generating the least percentage of useful information, which are considered attack. The research aimed to reduce the dataset size from 3 dimensions to improve performance by reducing running time. KDD CAP dataset are used and PCEIG metrics are used to select the most essential features, resulting in a dataset with only 20 features in both training and testing dataset. The kernel of the GSK algorithm is replaced with a Busy recombination function chosen based on 7 metrics and the ACLI function. The developed GSK algorithm is then used to identify an important record by finding similar fitness value and filtering record with an equal fitness value, resulting in a 20% reduction in dataset size. Filtering record with a normal target from both dataset training and testing dataset also reduced the training dataset size by 19.69% and the testing dataset size by 19.48%. The MLP algorithm is used to train and test a model in 3 situations, resulting in an increased accuracy and reduced time requirement. Filtering a record with a normal target is found to be better method than filtering a record with a different fitness values. The main benefit of this approach is that it improves the efficiency and accuracy of the intrusion detection system by reducing dataset size and running time. Future research can explore the use of another deep learning algorithm to further improve intrusion detection system performance. Thanks for listening.